In this video, we are going to perform a titration with a strong acid and a strong base. So I'm going to work with sodium hydroxide. You can see that I've got sodium hydroxide flakes. And I'm going to work with very concentrated hydrochloric acid. So guys, if you ever perform a titration and you're working with very strong acids or bases, be very careful and wear your protective clothing. So first of all, I'm going to prepare my standard solution. So I want to make a sodium hydroxide solution with a known concentration. So my concentration that I want is 2 moles per cube decimeters. And if you work out with molar ratios, you work out with the calculation, you will see in one of my videos, I'll do the titration calculation for you. You can measure out the exact mass that you require to make up a 2 moles per cube decimeter solution. So because these flakes are a little bit larger, I'm just going to pour it in here without a funnel, trying not to waste any of those. Okay, and you want to make sure that you qualitatively transfer everything, which means everything that was in here should now be in here. Okay, quantitative transfer. Alright, so now I'm going to take my distilled water and I'm just going to add a little bit of distilled water, and you will feel that the flask is going to heat up because it's an exothermic reaction, so it's going to get really, really hot. So you don't want to put your hand here, otherwise you might just burn yourself. So you're just going to add a little bit of water first, and then you're going to give it a nice shake to make sure that all of your sodium hydroxide dissolves before you fill up the volumetric flask to the mark. So I'm just going to give it a nice shake first. Okay, you can see it's dissolving really quickly. Okay, sodium hydroxide is hygroscopic, which means that it absorbs air, moisture from air, and then it becomes quite moist. So you can see that I'm adding my distilled water. There's still one flake down there that I need to dissolve. So I'm just going to give it another shake before I fill it up to the mark. Alright, so when this is done, this concentration should be 2 moles per cubed decimeter, as we have calculated it. Right, it's almost completely dissolved. Now I'm just going to take my bottle with distilled water and I'm just going to add it slowly until my solution has a meniscus that's just above the mark. So you want to be really careful here. You don't want to go over that mark, otherwise your solution volume will not be accurate. Okay, so that's very close. So if you are scared of going over the mark, you can take a dropper pipette and maybe just add a drop of 2. Put in the last little drop or 2 drops that you need to get that meniscus exactly above that mark, because if it's not, your volume will not be accurate. And if your volume is not accurate, then your concentration will be wrong. Okay, and now you have your prepared sodium hydroxide solution. So I'm going to use my pipette now, and I'm going to take 25 milliliters of the solution and put it into my Erlenmeyer flask. Okay guys, when you do a titration, make sure that your equipment is clean beforehand. So you have to wash everything with distilled water before you actually use it. And you can even rinse your pipette with your base before you pipette your final volume. Okay, so be careful here, check that that is exactly where you want it. That's perfect. And now you're just going to transfer it into your Erlenmeyer flask, tilting your beaker to make sure you get every single drop out of your pipette. And now if we're done pipetting the solution, we're going to add our indicator. So with this titration, we're using bromothymol blue because we're titrating a strong acid with a strong base. And that's why we use bromothymol blue. That shows a very good color change in that range of strong acid and strong base. Right, so that's done. Okay, so now you have your solution in here. So I'm just going to add 1 or 2 drops of bromothymol blue. Okay, and remember that it should be blue in a base. When we start adding your acid, remember your acid shows a yellow color with bromothymol blue. So when you do your titration, the end color, the end point color that you're searching for is going to be a green color. So before I start with my prepping my acid solution, I'm just going to take another equivalent of 25 milliliters of my base and put it into my second Erlenmeyer flask. So now remember, you can keep this solution with you whilst performing your titrations, because if you make a mistake or you do maybe 3 or 4 titrations, then at least you know you still have enough of your base left to perform multiple titrations to get that average value, and that is what you're searching for. The most accurate titration. So I'm just going to add this again, but to this solution I'm not going to add my indicator as to yet, because you would only like to add it just before you start with your titration. So I'm just going to add this quickly, and then I'm quickly going to prepare the acid that I need to dilute that will then go into your burette. Right, almost done. Just tilt your beaker to get that last drop in. There we go. Alright, so you can keep this solution, maybe put it into a beaker and store it if you only have 1 volumetric flask. If you have another volumetric flask, go and grab it, because we're going to have to use this now to dilute the acid. Okay, so I'm now going to dilute my acid. So remember guys, this is very important. Whenever you dilute an acid, you never add the water to the acid. You always add the concentrated acid to the water. So I'm putting into my volumetric flask, I'm adding my water first, and then only will I add the concentrated acid. Okay, the reason why we're doing this is because it's also quite very exothermic, and it can explode into your eyes if you don't add the acid to the water. So I'm just going to add it very slowly. Okay, you can see it's quite concentrated as it makes those lines at the bottom of the flask. It's quite interesting. And now you just want to wash out your funnel and then fill your volumetric flask up all the way to the mark. Alright, so I'm just going to add in my last bits of distilled water, fill it up to the mark. So we don't know what the concentration of this acid is. That's the purpose of doing the titration. Okay, the purpose is to determine what is that concentration. I'm just going to add 1 more drop there because I don't want to go over the mark. Make sure that meniscus is exactly above that mark on the volumetric flask. Alright, so now I've got my acid prepared and diluted. I'm just going to give it a good shake. Make sure that your tap is closed before you shake it, your stopper. Okay, and now this is ready to go into your burette. So your burette, you can wash it with soap and water, and then you can wash it with distilled water, and then you can wash it with a little bit of your acid to make sure it's really, really clean and that your titration would be accurate. So I'm going to put in my funnel. Make sure that your tap is closed before you add your acid. And just to be safe, you can maybe take away your Erlenmeyer flask and just put a waste beaker there. So I'm just going to move this a little bit down so that I can reach the top. Okay, and now I'm going to put this into my burette. Okay, it doesn't have to be exactly on 0. Doesn't have to be, but if you like to have things very perfect, then it won't make a difference. Right, so let's see what the initial volume is. Before you check your initial volume, just make sure that you don't have an air bubble in here. And if I look at this here, I'm just going to open it up, let it run a bit, and then close it again because I don't want any air bubbles. There we go. So there's no air bubbles in there. So I'm just going to record my initial value. Okay, you want to look perpendicular to your eye. So I'm going to have to take the burette off. And if I look at this is exactly 0.90 cubed centimeters. So I'm going to place it back. And then you're ready to start with your titration. Remember, when you start with your titration, to remove your funnel. Okay, so you can do a rough titration first, where you add lots of acid and then see the color change, or you can work accurately from the start, and then you only have to do, let's say, 2 or 3 very accurate titrations and get the average value. Okay, so right at this moment, I've got sodium hydroxide in here, 25 milliliters, and remember, it's basic. In my burette, I've got hydrochloric acid with an unknown concentration. So this is what you want to work out, is what is the concentration of the acid in my burette. So the pH of the acid is very low. When you combine the two solutions, you're going to neutralize the solution, and therefore you will get a neutral pH, and that is why your indicator is going to change color. Okay, so I'm going to open up my tap, and while the acid is running inside of your Erlenmeyer flask, you need to swirl your flask continuously to make sure that everything mixes well. And you can let it run until you start to see slight changes in the color. Then you know that you should stop and maybe just add 1 or 2 drops at a time. Okay, guys, remember what the initial volume was. You don't want to forget what your initial and final volume is, otherwise your calculations is going to be completely wrong. Okay, so I don't see a color change yet, but I can definitely see that it's getting lighter in color. Remember, we're looking for a sudden color change, and it's probably going to be a green color, because remember, bromothymol blue in acid is yellow. So between blue and yellow, you will have a green color. Look at that. Sudden color change. Okay, now you can see the color is actually yellow. So this means that I have over titrated, and I add maybe 1 or 2 drops too many, which is fine, because now you have your rough titrant. So now you can record your final volume, and if I look on my burette here, I can see that is 32.30 cubed centimeters. So you can work out the difference in this volume. So I'm quickly going to grab my calculator. Okay, so on my calculator, to get the change in volume, you take the final volume on your burette minus the initial volume. So the final volume was 32.30 minus my initial volume that was 0.9, and I can see the volume that I required was 31.4 cubic centimeters. So I'm now going to repeat the titration, but I'm only going to add, let's say, about 25 or 27 cubic centimeters of acid, and then I'll stop my burette and start adding drops to make sure that I don't over titrate to get this yellow color. Okay, you want to get a green color. So let's repeat that. So remember to add your indicator. Otherwise, you're going to keep on titrating and nothing's going to happen. And then you'll just waste chemicals. All right. So we have a nice blue color. I'm just going to add one more drop, just so that we can really see a good color change. Okay, now I'm just going to, you can maybe just add more acid because you don't want to run out of acid in your burette. So I'm just going to add more acid. Make sure that your tap is closed. You can add more acid. Okay, and now you can record your initial value of your acid. So let's have a look here. I'm going to take this off again quickly, just to check what's my volume. Okay, we're looking at 2.30 cubic centimeters. Okay, so you need to write that down because you don't want to forget that. So 2.30 plus 31.4 is going to give you a final volume of 33.7. So you're going to titrate all the way to, let's say, 31 or 30 and then add drop-wise until you get to 33.7. Okay, so let's do that. So I'm going to let it run all the way to 32. And then from there on, I'll just open my tap slowly to make sure that I don't over titrate the solution. Okay, you can see the color is going lighter already. So I'm just going to add slowly a bit. So I'm currently at 31. So remember, I want to go all the way to 33.7. So I'm just going to add a little bit at a time. Close it again, give it a good shake. See if there's any color change. If you don't see a color change, just continue adding small drops at a time. Okay, I'm currently at 33 cubic centimeters. So I'm just going to add one drop at a time, give it a swirl. Okay, you need to have a lot of patience when you do titrations. Sometimes it takes a lot of patience to be a good chemist. Okay, so you can see that the blue is fading a little bit, so I'm just going to add one more drop. Let's hope this is the drop. Yes. Okay, so you can see that one drop made the difference. So you can see that now the color has changed suddenly. So we've reached our end point. Okay, so you have to record your end volume. So it's 34.40. All right, and you can check the calculation that I'm going to do now, where I work out the mean volume that I require, and then we can actually then determine the concentration of the acid. Okay, so now you're basically done. So what we've made now by combining hydrochloric acid and sodium hydroxide is basically a solution of water and sodium chloride. So it's basically a salt water solution. So if you want to, you can pour this solution into an evaporating dish, and you can let it stand overnight, and then the next morning you should get nice sodium chloride crystals forming on your evaporating basin.